Hi there, and welcome to this lesson. In this lesson, we'll be learning linear equations, okay? And under linear equations, we'll be learning to solve simple linear equations. Now, as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch, okay? We would be more than happy to help. Okay, let's jump right into the lesson. So linear equations, simple linear equations, solving simple linear equations. Now, what exactly are linear equations? Now, linear equations are algebraic equations that contain a single variable of the first order. Okay, so what is this? A single variable of the first order. Basically, you have an equation like this: x plus 1 equals 5. This is a fairly simple linear equation, and it contains a single variable x of the first order. Basically, the first order, i.e. x to the power of 1. If you had a variable of the second order, you'd have x squared. Okay, so but in this case, we have a single variable of the first order, x plus 1 equals 5. Now, what this is simply asking is, what would you add to 1 to give you 5? And I believe you'd agree with me that the number would add to 1 to give 5 is 4. So in this case, x is 4. Now, similarly, you can have another equation like this. Basically, we have 3y equals 21, or 3 multiplied by y equals 21. And it's pretty much asking the same question: what would you multiply by 3 to give you 21? Okay, and the number you multiply by 3 to give 21 is 7. So in this case, y is 7. So basically, equations do get more complicated than this, but this is pretty much the basis. Okay, and now, we were able to arrive at these answers basically by merely looking at the equations there, but there are actual processes that we use in solving equations of this form. So the first we'll talk about is equations like the first you had there, okay, where you have x plus 1 equals 5. Now, when you're solving equations that involve a number being added to or subtracted from your variable, you move across the equal sign. Okay, and I'm just going to explain exactly what this is. So we have x plus 1 equals 5, and basically what we do is we move 1 over to the right. Now the idea, basically, just think about it: anytime you're solving simple linear equations in this form, what you want to do is you want to have your variable on the left, okay, and then you want to eliminate everything else. You want to move everything else over to the right. You basically want to end up with just x on the left and all the other numbers on the right. So when you have something like x plus 1 equals 5, what you do is you try to move the 1 over to the right, and here's how we do it. So we have x plus 1 equals 5, and we're moving plus 1. Okay, anytime you're moving the number, you move the sign in front of it alongside it. So x plus 1 equals 5, and we're moving plus 1 over to the right, and what we have is we have x equals 5 minus 1. Okay, that's the trick. So anytime a number moves across the equal sign, the sign in front of that number changes. So plus 1 becomes minus 1, and minus 1 becomes plus 1. If you had, for example, if you had minus 1, if you had minus 7, and you moved minus 7 over to the right, it becomes plus 7. So in this case, we had plus 1, and we've moved plus 1 over to the right, and it's become minus 1. Okay, so we have x equals 5 minus 1, and when we solve x equals 5 minus 1, we have x equals 4. Very simple idea. Anytime you're solving linear equations, just remember this: you want to have all the numbers on the right and your variable on the left, or variables on the left. Sometimes you have the same variable but just more instances of that variable. So you want to have all your x's on the left and all your numbers on the right. And once you achieve that, it's pretty much just solving it out. So that's the first one, moving across the equal sign. And like I said, we apply this whenever we have a number that's been added to or subtracted from our variable. Now, what about instances where you have a number multiplying your variable? For example, when you have 3y equals 21. Remember, the general idea is to get all the numbers, including the coefficients. Okay, so basically we have 3y equals 21. We don't want to have 3 on the left. All we want on the left is just our variable, i.e. y. We don't want anything multiplying y. We need to get rid of that 3. So how do we get rid of the 3 there? Okay, so we have 3 multiplying y. What we do is we divide 3y by 3. Okay, because if we divide 3y by 3, we eliminate the 3 on the left. Okay, but then anytime we divide on the left, we have to divide on the right as well. So we divide both sides. Okay, so you divide 3y by 3 and you divide 21 by 3, and basically you have 3 cancelling out there, leaving you with y as expected, and then you have 3 cancelling out there, and basically you're left with 7. And what you have is you have that y equals 7. So the general idea is to eliminate. So anytime you have a number multiplying a variable, you pretty much just divide both sides by the coefficient, divide both sides by the number multiplying that variable. And yeah, once you've understood these two things, you can solve pretty much any linear equation. So, and let's go ahead and do that. So example 1. And example 1 says, if m minus 17 equals 31, find m. It's a fairly simple one. Okay, and we have m minus 17 equals 31, and basically we have a number, we have a variable m, okay, and we have a number subtracted from a variable m, i.e. 17. And remember, we want to get our variable on the left and all the numbers on the right. So we don't like minus 17 sitting there. We want to move minus 17 over to the right, and this is how we go about doing this. We have m equals, we move minus 17 over to the right, it becomes plus 17. Okay, so m equals 31 plus 17, and when you work that out, you have m equals 48, and that's it. Very simple, very straightforward. Let's move on. So example 2. Example 2, now we have a very interesting one here. We have 7p equals 42, and we've been asked to solve for p. So in this case, we have a number that's multiplying our variable. Okay, and 7p equals 42, find p. How would we go about doing this? So 7p equals 42. We don't like 7 sitting there. Remember, all we want on the left is our variable. We want to eliminate every number. All the numbers should be on the right. So we don't want 7p sitting there, and 7 is multiplying p. So what we do is we divide by 7 and divide by 7 on the right as well. So we divide both sides by 7. And when we do that, we actually cross this out. And 42 divided by 7 is 6. And what you have is you have that p is 6. Let's do another example. Now example 3. And example 3 says, if 2c plus 4 equals 19 minus 3c, find c. Interesting. So now we have something quite interesting here, because we have two instances of our variable in this case. Okay, so we have 2c and we have 3c on the right as well. So how do we approach this? Now we're going to move, the first thing we're going to do now is we're going to move numbers around. Okay, that's the first thing we do, because we want all our variables on the left. Okay, we want all instances of a variable. We want all the c's on the left and all the numbers on the right. So I'm going to move, the first thing I'm going to do, I'm going to move 4 plus 4 over to the right. Okay, and what I have, take it over to the right, and I have it as minus 4. Okay, now we have minus 3c on the right. We're actually going to move that to the left. Remember, we want all instances of our variable on the left. So basically I have minus 3c moving over to the left, it becomes plus 3c. So what I have is 2c plus 3c equals 19 minus 4. And then when I solve that out, I have 5c equals 15. Now that is the first step. So we now have 5c equals 15. We have a number multiplying our variable. 5 is multiplying c, and we're looking to get rid of that 5. We don't want that 5 there. Remember, all we want on the left is our variable. So 5c equals 15. And what would we do in this case? We'd simply divide both sides by 5. And basically what you have in the end is you have 15 divided by 5 is 3. So what you have is c equals 3. And that's it. Very simple. Okay, so when you have an instance like this, the first thing you do is you move your terms across the equal sign to try to get all instances of your variable on the left and all the numbers on the right. And remember, anytime you move anything, be it a term like an algebraic term or a number, the sign in front of that number changes. Okay, so if you, like we had minus 3c, when we moved it over to the left, it became plus 3c. And then once you've done that, you should end up with an equation like this, simple equation, something like 5c equals 15. And from that point on, you just divide both sides to get your final answer, c equals 3. Okay, I think we have a few more examples. Example 4. And example 4 says, this one is looking more interesting now. So we have if 4k minus 5 minus 2k equals 31, find k. So we have a bracket here, and basically we need to open up this bracket. Okay, so we have 4k minus 5 minus 2k equals 31, find k. Now the first thing we want to do, like I said, is open that bracket. And basically opening that bracket, we have minus 5 because we have a minus on the outside, so minus 5, and then we have minus 2k, and minus 2k becomes plus 2k. Okay, I believe you'd recall this from the last previous lesson where we talked about expansion of algebraic expressions. So you have a minus on the outside of the bracket, you apply that minus to the 5, it becomes minus 5. You apply the minus to the minus 2k, it becomes minus 2k. And anytime you have minus 2k, minus becomes a plus. So we have 4k minus 5 plus 2k equals 31. Okay, so what do we do from this point? Now we have a number on the left, and we don't like numbers on the left now, do we? So we're going to move that number over to the right, and what we have is we have we opted to simplify first. Basically we have 4k plus 2k, make that 6k minus 5 equals 31, and then we're going to move minus 5 over to the right, and what we have is we have 6k equals 31 plus 5, and we have that 6k equals 36. Now the next thing we're going to do, we have 6k equals 36. We're simply going to divide both sides by 6, and basically we end up with k equals 6. Now our final example, so we have example 5, and example 5, if 4 multiplying 3f minus 1 equals 11 f minus 3 multiplying f minus 4, find f. It looks a bit, but it's actually simple. Let's get into it. So now it's just expansion. Okay, the first thing we need to do here is just basic expansion, and then we expand what we have on the left. We have 4 multiplying 3f, we have 12f. 4 multiplying minus 1, we have minus 4. Okay, and expanding the brackets, opening up the brackets, we have on the right, we have minus 3 multiplying f, we have minus 3f, and minus 3 multiplying minus 4, we have plus 12. Now when students attempt questions like this, it's so easy to make an error with negative signs. So you should be mindful of that, very much mindful of that. It's happened too many times. Students lose marks because they just missed out a minus sign. They get the whole process right, they get the method right, they get all the steps right, but then just a small error there just cost them the answer. So you should be quite mindful of your negative signs. So now we have 12f minus 4 on the left, we have 11f minus 3f plus 12 on the right. Now I believe you know exactly what to do here. We're going to move all, simplify, and move all the instances of f over to the left, and then have all the numbers on the right. And basically we have, we'll simplify. 11f minus 3f gives you 8f, okay? And then we're going to move around. So we move 8f over to the left, it becomes minus 8f, okay? And then we'll move minus 4 over to the right, it becomes plus 4. And then we work that out. So 12f minus 8f is 4f, and 12 plus 4 is 16. And basically we have 4f equals 16. And then the next thing we want to do, 4f equals 16, we're going to divide by, yes, 4. And basically we have 4, we're left with f, and we're cancelling out here, we're left with 4. And what you have in the end is you have that f equals 4. And that will bring us to the end of this lesson. Very, very simple lesson. If you're going to take anything from this lesson, just remember, when you're solving simple linear equations, you want the variable on the left and everything else on the right. And once you've got the two concepts, basically moving across the equal sign, knowing that the sign on every term changes whenever you move across the equal sign, and then dividing both sides by the coefficient of the variable. Once you know that, you pretty much have zero problem solving any linear equations. They can even come in pretty complex looking forms like we had in example 5, but once you expand and simplify and just apply those two basic principles, you pretty much should be good with any linear equation you come across. And yeah, bye for now.